Hello and welcome back. We have a real treat for you coming up right now with Astellas US and Kruger Consulting. Please welcome Akansha Saxena and Kurt Kruger. Thank you guys for coming.
Hi, everyone. I guess Akansha has the slides.
Hi, everyone. Hope everybody can hear me well. Some technical problems we were facing. My name is Akansha, and also I have with me Kurt Kruger. You guys must be hearing him just a couple of seconds before in another presentation. Both of us are going to present today our case study that we've used AnyLogic in simulation of behavioral economics, and specifically as applied to organizations. Just a disclaimer that anything which we present here are our individual opinions and not connected to Astellas. Just to add in here. And here's the agenda. So what we want to show here is just going over background for behavioral economics. Then we'll talk about the model, then our findings, and then conclusions. So let's go to the backgrounds. Overall, what we really want to show here is that behavioral economics is essentially a method which is a method for economic analysis that combines concepts of behavior science to explain economic decision making. And it is a known concept. A lot of people, of course, have been hearing about it. The classical economic models were built with the assumptions that people are rational and predictable. But in recent years, advances have been made in combining behavioral science concept with classical economic theories. And you might have already heard the Nobel Prize in 2017 was actually presented for behavioral economics to Richard Thaler, Daniel Kahneman, and Tversky. So overall, this theory essentially, one of the most popular theory in behavioral economics is prospect theory, which states that human decisions are not always optimal, and our willingness to take risks is influenced by the way in which our choices are framed. So essentially, they are context dependent or driven by biases. But if we target these biases or change the context, then rational outcomes can be achieved. And many different biases are studied in behavioral economics. And some of them we are listing here. They are not all. There are many more, which, of course, in the literature we can find. Loss aversion, status quo, herd behavior, spotlight effect. Many of these are studied in this particular field. And that's what can be targeted in order to create a positive or a intended outcome. So our use case is essentially around organizations, and we considered organizations as a good use case for applications of behavioral economics theories. And the reason we considered that was because organization is made of people, and the decisions of people are impacting the performance of the organization. And it is essentially an interplay between the rational and irrational decision making that is creating whether a short-term or a long-term impact. But in reality, the organization is also composed of systems and subsystems. So it is essentially a systems problem. And that's why AnyLogic comes in, and that's why the entire system science comes in, that can we combine behavioral economics with the system science and generate some simulations which can then help us identify what is the impact of people's decision making on the company's performance or not. So in our use case, what we have tried to bring together is we've tried to apply agent-based modeling And agent-based modeling is essentially employees being simulated. So any concepts of behavioral economics, we are applying on how the agents are taking their decisions. But then what happens after that is essentially the systems approach. And then we are able to hopefully identify any unintended consequences, also emerging behavior of the organization through this. So the next slide, I am going to actually pass it on to our collaborator, Kurt, who can actually give a description of the model and then how we brought all of this together. So Kurt, on to you.
Great, thank you. Just to check, Akansha, can you hear me? Okay. So the model that we've been building here, it's really an initial project to help us learn how to ask the right questions. A lot of the questions that we're after is, they relate to the building of trust within teams and the role of psychological safety, looking at team productivity, organizational performance. So in combination with some work that's already happening at the company, where we're using this modeling to help us frame a lot of the initial questions that we should ask. So we're talking with different stakeholders and we're looking at what are some of the big features, what are some of the big key points that are likely to come up. So the initial model that we built, that we're building, it's a model that looks at the interaction between different teams and how those teams work sort of within themselves, and then at some point how they work, in collaboration between different teams. So through this process, through this engaged process of sort of the back and forth of building the model, our model is basically a situation where we can control the number of teams and the size of each team, so that we have agents within those teams operating. And, at different levels of size, we can look at how the dynamics of trust develop over time differently for small teams versus large teams. And we're also exploring, the nature of the questions that they're being asked. So there may be some teams working on research-based approaches where the uncertainty is pretty high, the level of success is maybe kind of low. And there's other teams where maybe the success is a little bit more predictable. And so that dynamic or that dimension to this question we've added to the model. And then we're looking at how, we can also look at how established teams versus new teams may play a role at the development of trust over time. So this simplified model essentially has a number of teams in it with a number of interactions. So if we go to the next slide, then we can have the model running, and then we can look at there you go. So that's an example of an early version of this model running. Just with one team, we can see that there's a number of agents within the space, and they're interacting with each other based on sort of a number of tasks that are given to the community or to the group of agents. So we give the agents a number of tasks, and those tasks require collaboration between, in this case, two different agents. And then those agents come together and they essentially play a sort of a modified form of a game theory approach. It's modified because we want to allow the sort of game theory approach to change over time based on the level of trust that's been developed. So we're focusing on that kind of dyadic trust between any two agents in the model, or any two agents who are interacting with each other. So that's what we see on the left. And then in the middle one, we can see the trust matrix that we've built out, which is just showing a white square for high trusting relationships and a black square for a low trusting relationship. So this is a model with 100 agents, I believe. And so we can look at the trust dynamics over time, and we can see if we have a team where there's a high amount of trust or a low amount of trust, or maybe within a team there's certain sort of sub-cliques that are forming. So this trust matrix allows us to explore that. And then on the right, we can look at productivity under a number of different ways of measuring it. So obviously the easiest way to measure productivity would be to just sum the individual productivity across all the team and individuals, but there's other ways that we could characterize productivity as well. And so that's looking at, in this case, we have a team that starts off with a relatively high amount of productivity, and then based on the team size and the type of question that they're being asked, that productivity might degrade over time. So we can begin to ask questions, what might we do in order to get that productivity to increase over time, or to at least be stable over time rather than fall off. So I think that's it for me, and Akansha will take over for the next few slides.
Okay, let's go to the findings. So the first finding, I would say, after we build the model, we are showing here essentially how actually what Kurt was also describing, the productivity and the trust. So on the right-hand side is the trust matrix, which we described in the previous slide. But then, so what we try to see is that as we change the penalty of interacting with people, which is where we applied the behavioral economics model, what happens to the productivity of the entire team? So you can see the variation in the productivity. And this is kind of a validation from our side that is the model actually working as we are expecting or not. So this is just in that respect a validation. But then we started to actually go and test out certain different changes or set up experiments. And this is one of the experiments which we set up, that we wanted to find out how does the model or the model is answering questions on, is there a variation on team sizes? And if there is a variation on team sizes, does the trust change or the productivity changes or not? And I'm not showing the productivity here, but essentially what we see is that if we run the model with smaller team sizes, then we see that the teams have extremely high trust. But then if the model has larger teams, maybe 100 people in one team or 50 people in one team, then the trust definitely goes down relatively. And the productivity actually follows the same trend, which is not showing in this particular slide. The other type of factors we actually tested out in this model was what happens if we actually give these teams tasks which are either collaborative tasks or individual tasks. And the idea here was that if the people are interacting with each other, and they have to have a collaboration, because if it's a pair task, then does that require a lot of trust, or does that have an impact on trust or productivity or not? And so what we found was that if we have a smaller team with a lot of paired tasks, then essentially a small team with a lot of paired tasks is fine, because they still have trust enough for them to produce high productivity. But as the team starts getting larger, the trust goes down. And if you also throw in the complexity of having paired tasks in a team, then the trust goes down further, and the productivity follows the same aspect. So again, we're not showing productivity here, but then paired task and larger teams is essentially telling us that the trust would be low. And then if we want to really target to increase the productivity, we'll have to think about whether we can play around with the team sizes, reorganization, or we should be play around with the type of tasks these teams have. So those are the three use cases as in three kind of results we have obtained in the model. We're still working on this particular model, and then we are trying to generate more answers. But in conclusion, what we found was that we were able to apply agent-based model to essentially combine behavioral economics principles and then apply it to the organizational settings and simulate employee interaction. The model definitely helps us identifying what could be the targets that we can change, and then can we create nudges or not. So essentially, once we know what nudges we can create, this model will also help us in assessing the impact of these nudges, and then how they can lead to a positive or a negative result. And we also are also able to already see any unintended consequences of the changes which the organization makes. Say the team size is a very good example. So as I said, we are still working on it. So the future avenues for these models would be to determine team sizes that are optimal team sizes, simulating the impact of bad employees, simulating change in strategic directions, and even interdepartmental collaborations and communications. And overall, we believe that these models can actually help organizations improve on their strategies, structures and processes, and also focus on influencing the decision of their employees who are essentially helping the company be successful. That's all. And if anybody has any questions, I'll be happy to answer.
If I can offer one thought here, I think one of the valuable approaches of one of the benefits of using a modeling approach like this is that it allows us to ask questions as we develop the model. So some of the byproducts of the modeling process has really been telling us what types of questions we should ask of various types of surveys that are being done, to understand how that survey data should be interpreted, for example. So if there's an impact, if we're looking at a survey data and we don't know if the population within that who's asking that survey are from a large team or a small team, then the way we interpret that data might be colored by our understanding of the mechanics. So the modeling is really a helpful thinking tool, at least at this early stage of development. Akansha, do you want to try this question? Sorry, just working on some technical difficulties here.
Hi, so there's a delay, and so there is a question which I see here, that why did we use prospect theory in its axiom? So I would say prospect theory was actually more which we used to describe behavioral economics, but within the model, we are actually not exactly applying prospect theory, but we are trying from game theory, we are taking other different modeling approaches. But we are still testing out what is the best approach we can take. We have right now we are applying prisoner's dilemma essentially in the model. I hope that answers your question.
Well, maybe I'll just add one more piece to that. There's a couple different. We've explored a number of different sort of game theory games, and then we've definitely modified them because game theory games are not often built in an environment where the trust level, you consider sort of the trust between different agents and how that trust may be evolving over time. So we've definitely experimented with Prisoner's Dilemma, with this. The stag hare game and other types of games. So yeah, go ahead, Akansha, you can take that one.
So the next question I see here is, do we use relational or network data in our model? Right now, not yet. We are actually building the model to understand if we can test the hypotheses and test what's happening in the, what are the known theories in the organization. But we will be moving towards maybe combining it with any network or relational data, but not right now.
I believe that we do have a goal of combining it with some survey data that's currently being done.
Okay, thank you, Kurt and Akansha. It's been 24 hours of simulation talk, and it's always exciting to see a new use case, so thank you so much. And as always, if you think of any questions after the presentation, please email both of the presenters. Their links are in their bios. Thank you.